Okay, this is the video for the 3D geometry test. These are all the review questions. Find the volume of a rectangular prism with a length of 8, a width of 12, and a height of 4 centimeters. Most of you know the volume formula for a rectangular prism. It's length times width times height. So this is a very easy question. Volume 8 times 12 times 4. And we have 384. This would be centimeters cubed. Number 2 says we want to find the surface area of a rectangular prism that has a length of 8 feet, a width of 6 feet, and a height of 10 feet. Remember, surface area are all the areas of all the surfaces added up together. So on a rectangular prism, we have 6 surfaces, okay? So our dimensions of the prism are 8, 6, and 10. If you notice, the bottom and the top are the same. So I'm going to draw a rectangle which represents the bottom. And 8 times 6 is 48. That's its area. But we have 2 of those. We have the bottom and the top. So I want to multiply that 48 by 2 and get 96. Okay? Now we have to make another rectangle. This one will represent the sides. The sides, what I mean by the sides, would be that. So our dimensions there would be 6 and 10. 6 times 10 is 60. But I have a left side and a right side. So I want to multiply that by 2 and get 120. We did top and bottom. We did left and right. And now we need to do front and back. Front and back would look like this. 8 and 10. 8 times 10 is 80. 80 times 2 is 160. Now we can add up all 3 of these numbers and get our final answer, which is 376. Since this is an area, it would be feet squared. Number 3, find the lateral area of a cylinder that has a diameter of 11 and a height of 16 in terms of pi. So lateral area of a cylinder formula comes from your formula sheet. It's L equals 2 pi RH. That comes right off the formula sheet. You just have to read for lateral area and the word cylinder. All right, so we can fill this formula in. We have 2 pi times the radius. If the diameter is 11, the radius is 5.5, and the height is 16. We are leaving the answer in terms of pi. So what that means is that your answer needs to have the pi in it. So I see the pi here. I'm going to leave it alone. I'm going to bring it down on my final answer, and all the other numbers need to get multiplied. So the 2, the 5.5, and the 16 need to get multiplied together. I'm not going to multiply the pi. 2 times 5.5 times 16 equals 176. So we have 176 pi feet squared because this is a lateral area. So in terms of the cylinder, what that means is think about the Campbell's soup label. The lateral area is how large that label is. Okay, number 4, a cylinder has a volume of 800 cubic inches. If the height of the cylinder is 12, find the length of the radius to the nearest tenth. Cylinder volume, we need the formula. Well, that would be big B times H. That's off the formula sheet. What's not off of the formula sheet is the following. Big B represents the area of the base. It's a cylinder, so the base is a circle. Area formula for a circle, pi r squared. Volume is 800. So I want to plug that in for big V, for V. We have pi, we have the radius, and we know the height is 12. We always said in class the 12 should go to the front. So we have 800 equals 12 pi r squared. So now what we need to do is we want to solve, this equation now has one variable. We want to be able to solve for the radius. We want to find r. So now we need to algebraically isolate r. So the first move is to divide by 12 pi. Many of you got this wrong on the quiz. You need to do in your calculators, this is so important, you're going to get this wrong if you don't do it this way. 800 divided by parentheses 12 pi. If you don't include the parentheses, you're not dividing by 12 pi. You're dividing by 12, getting an answer, and then multiplying by pi, which is not appropriate. So here's our answers, 21.220,65908. So 21.220,65908 is r squared. And now to undo the square on r, we're going to take the square root. So we get r equals the square root of that number. So square root of 21.220,65908, which is equal to 4.6065, blah, blah, blah. We were asked to round to the nearest tenth. That answer rounded to the nearest tenth would be 4.6, and it would be in inches, because it's a radius. Number 5 says, find the lateral area of a cone that has a radius of 4 meters and a slant height of 9 meters to the nearest hundredth. Again, lateral area of a cone coming from the formula sheet. Formula is big L, lateral area is pi r script L, and script L stands for the slant height. It says that on the formula sheet. The radius is 4 meters. The slant height is 9 meters, so we can just plug all this in. We want us to the nearest hundredth, so we are going to type in pi on the calculator. We're not going to keep pi in the answer. So we're going to do pi times 4 times 9. And that equals 113.097. Rounded to the nearest hundredth, that would be 113.10. The 0 is important because it signifies that you are rounding to the nearest hundredth. Without the 0 there, I'm not sure where you're rounding to. You could be rounding to the nearest tenth. So 113.10 meters squared, because this is area. Number 6. A cone has a lateral area of 60 pi inches squared. Cone has a lateral area. We need to write down the lateral area formula for cone. It's pi RL. We're being asked to find the altitude of the cone. Anytime we're dealing with a cone, you should always, unless it's something where they just give me numbers to plug in, you should always draw the picture of the cone. So here's my cone. Here's the triangle that lives inside the cone. Diameter is 12. That means the radius is 6. There it is. We want to find the altitude of the cone. Well, the only information we know is that the lateral area is 60 pi. So I'm going to write 60 pi equals pi RL. Well, we also know that the radius is 6. And I will put the 6 pi in the front on the right side. And we're going to divide by 6 pi to find L. The pi's cancel, and 60 divided by 6 is 10. L stands for the slant height. The slant height is just that. It's the slanty part of that triangle that you drew. 6 is the radius. We were asked to find the altitude, A. So we have the right triangle in the cone. Proceed to the Pythagorean theorem. A squared plus B squared equals C squared. A squared plus 6 squared equals 10 squared. A squared plus 36 equals 100. Subtracting 36, we would get A squared. A squared is 64. Taking the square root, the altitude is 8, and it would be measured in inches. Final answer. Number 7, a regular pyramid has a square base. So on the side here, I'm going to draw a square base, put a point up here, so I can draw the pyramid. Okay, and the bases each measure 15 feet. The edges do, rather. And if the altitude of the pyramid is 12 feet, or the height is 12 feet, find the volume of the pyramid. Volume of a pyramid formula on your formula sheet. 1/3 big B times H. Big B is the area of the base. Since the base is a square, I can do side times side, or side squared. So I'm going to replace big B with 15 times 15. So I'm going to have my volume which is 1/3, times big B is going to get replaced with 15 times 15, coming from the base of the pyramid, times the height of the pyramid. The height of the pyramid, or the altitude, was 12 feet. And now we can just plug this all into our calculators. We have 1/3 times 15 times 15 times 12. Enter. 900. 900, it's volume, so units on volume are feet cubed. Next question, number 8. If the volume of a cone is 800 pi cubic millimeters, so again, I read volume of a cone. So on my paper, I look up the volume of the cone formula on my formula sheet. It's this. And the altitude is 24. They want us to find the lateral area of the cone. So I'm going to write down my lateral area of the cone formula from the formula sheet. Big L equals pi r script L. Now, we need to draw the cone. You always draw the cone. Here's the cone. And inside the cone is a right triangle. Well, what do we know on that right triangle? The altitude is 24. And right now, that's it. The other piece of information we knew was that the volume was 800 pi. So we're going to start by filling in that number for the volume. That's 800 pi equals 1/3. Big B, since we're in a cone is a circle base, gets replaced with pi r squared times the height, or the altitude, of the cone, which is 24. So we get 800 pi equals 24 times 1/3. Can simplify to 8 pi r squared. And now we're going to solve this equation for r. So the first thing we're going to do is we're going to divide by 8 pi. The pi's cancel. 800 divided by 8 is 100. Equals r squared. We're going to take the square root on both sides. And r is 10. So from the volume, we were able to generate the radius. Now, lateral area. Lateral area is pi times the radius times the slant height. So we have pi times the 10 times, I don't know the slant height. We need to use the Pythagorean theorem to find the slant height. So a squared plus b squared equals c squared. 24 squared plus 10 squared equals c squared. 24 squared is 576 plus 100 is 10 squared is c squared. 676 is c squared, taking the square root on both sides to get rid of the squared. C is 26. That is your slant height. We're leaving this in terms of pi. That's what the directions say. So we're going to just do 10 times 26, which is 260. Pi units, millimeters squared would be the units. Number 9. Find the volume of a sphere that has a radius of 5 to the nearest hundredth. Volume of a sphere formula is on your formula sheet. V is 4/3 pi r cubed. Five goes in here, cubed. We want us to the nearest hundredth, so we can type in everything that we just wrote down into our calculator. So 4/3, I like to put that fraction in parentheses, times pi times 5 to the third. Rounding this to the nearest hundredth would be 523.60. Important. Feet, since it's volume, cubed. Number 10. A sphere has a surface area of 480 feet squared. Find the length of the radius to the nearest tenth. Surface area of a sphere, formula on your formula sheet, is 4 pi r squared. The surface area was 480. They would like us to find the radius to the nearest tenth. So now we plug in, for surface area, plug in the 480, and now we're going to solve for r. First thing first, we're going to divide by 4 pi. R squared is equal to, we're going to get a decimal on the calculator for this. Need to type this in correctly. Big mistake on the last quiz. 480 divided by parentheses 4 pi. So we get this number, 38.1971864. One more step, I have r squared. To remove the square, we take the square root. So we take the square root of the answer, or 38.1971864. And we get the 6.18, blah, blah, blah. Rounded to the nearest tenth would be 6.2 feet. Since it's the radius, you can measure that with a ruler. It would be in feet. Number 11, a fish tank with a length of 12 inches, a width of 5 inches, and a height of 10 inches is filled completely to the top with water. Fish tanks, rectangular prism. We have dimensions of 12, 5, and 10, filled completely with water. Mary wants to use a cone. So now we have a cone with a diameter of 4 and a height of 3. So here's my cone, and we're going to use it to scoop out. Diameter is 4. We don't like diameters. We like radii. Radius is 2. Height is 3, not the slant height, the regular height. If it doesn't say, you assume it's the regular height of 3 to scoop water from the tank. It says, what is the minimum number of full scoops that Mary must make in order to get the height of the water in the tank to be lower than 7 inches? So we want the height to go from 10 down to 7. So what happens is we want to remove a lot of water from this tank, namely this part here. I want to remove this green water from the tank. So we can figure out how much water we want to remove from the tank. We can figure out the volume of water we'd like to remove. So if the height is 10 and we want the height to be lower than 7, this remaining height had to be 3, and the other dimensions don't change. So the volume of the water we want to remove is 12 times 5 times, not 10, not 7, but the difference of the two, 3. So 12 times 5 is 60 times 3 is 180. Okay? We're going to take the cone and we're going to scoop out water. So my question is, well, what's the volume of the cone going to be? How much per scoop would we get out? So the volume formula for a cone from your formula sheet is 1/3 big B times H. So volume formula for a cone is 1/3. Big B is pi r squared because the cone is a circular base times H. So we have 1/3 pi. The radius of the cone is 2. The height is 3. So now, this is an applied problem, so meaning that it's not like it's not a theoretical problem. It's a real life problem. So I'm going to type in everything that's in the calculator so that we get a good answer, a good numerical answer on the volume of the cone. So we got 1/3 times pi times 2 squared times 3. So each scoop of the cone will scoop out 12.5663761 cubic inches of water. So each 12.5663761. Make sure I got that right. Okay. Now, I have to remove at least 180 cubic inches of water. Each scoop is going to remove about 12.5 or so cubic inches of water. To figure out how many scoops I'll need, I can divide these two. So for example, if you're not sure about the division there, let's say the volume of the cone was 60. So each scoop is worth 60. Divide 180 by 60 and you'll get 3 scoops. 60 plus 60 plus 60 gives you 180. So if you do it with a little easier number, you can see pretty easily why you need to divide. So it's 180 divided by 12.566 37061. And then what we get out of this is going to be a decimal. Okay? So we have 180 divided by, I'm just going to put second little negative sign for the answer. Whoops. Back, second, answer. And we get 14.32 blah, blah, blah. Now the question always here is well, what do you do with that 14? You can't scoop something out 0.32 times. So if you think about it, if I did 12.56637.061, and if I did 14 scoops, I would multiply by 14, and that would give me only 176 or so cubic centimeters of water, or cubic inches rather of water. I need to scoop a 15th time to get that height down to where I wanted it. It's going to be a little lower, but if you notice what the question said, okay, so now we're scooping at 188 or so cubic inches. The question said, what is the minimum number of scoops that Mary must make in order to get the height to be lower than 7? If we only scoop 14, we're going to be higher than 7. So that's no good. So we're going to round this number. We're not even rounding. We're just interpreting. We're making this number 1 bigger, because otherwise we're not going to get enough water out. So 15 scoops would be the final answer. I'm going to skip the 3D questions for now. I'm going to try to make a video of those. So I'm skipping on to number 18. The makers of Yummy Treats have received a great deal of complaints about their boxes of cereal not being filled to the top. A group of angry customers determined that the box was filled with only 144 cubic inches of cereal. If the cereal boxes have the dimensions in the figure below, Part A says, how high have the Yummy Treat people been actually filling the box? So if we think about something for a moment here, 144 cubic inches are what's in the box. Now when you fill up the cereal box, you're going to fill it up to a certain height. So we don't know what that height is. We know that the company is gypping us some cereal, but we don't know by how much. We do know that the 8 and the 2 are going to stay the same because they're not changing the box, they're just changing how high they're filling it with cereal. So volume of a rectangular prism, which is what this is length times width times height. We know the volume of cereal is 144. We know the length is 8, the width is 2, and we don't know the height to which they're filling the box up. We know how high the box is, but we don't know how high they're filling up the cereal. So we have 144 equals 8 times 2 is 16h, divided by 16, and h is 9. So they are filling this box up to 9 inches. That means they're leaving 3 inches to spare here. So part B asks us, how much cereal in cubic inches have they been saving by not filling to the top? Well, by not filling to the top, they're leaving this part of the box completely empty. This part of the box they're leaving completely empty. Well, we know it has a length of 8, a length of 8, a width of 2, and the height, since we know the cereal is being filled up to 9, and there's 12 in the entire box, 12 minus 9 will give you the height of what they're missing, which is 3. So now what we can do is we can figure out the volume of the missing space, which is going to be 8 times 2 times 3, which if we multiply that out is 48 inches cubed since it's a volume. And so the cereal maker is saving 48 cubic inches of cereal. All right, number 19 says find the volume of a cube whose surface area is 96 square inches. On a cube, there are 6 faces which are identical. Okay, so the surface area, there are 6 surfaces, and they're identical. So if we take our 96, which is all 6 surfaces added up, and divide by 6, we get 16, which is the area of one surface. Now, since this shape is a cube, the surface, any surface of the cube, is a square. Well, what do we know about a square? We know that every side on the square is equal to any other side on the square. We don't know right now how long the edge or the side of the square is, so we're going to give it a letter name. And the area is x times x, which is x squared. But we do know the area of one surface is 16. So we know that x squared, which represents the area of one surface, is equal to 16. Taking the square root, or some of you can actually figure this out in your head, x is 4. So now we know the length of one side or one edge of the cube is 4. That means all the other edges are 4 since it's a cube. The volume of a cube is the length times the width times the height. In this case, it would be 4 times 4 times 4. And 4 times 4 is 16 times 4 is 64. Volume is measured in cubic units. Our units at the beginning of the problem were inches, so this is inches cubed. So the volume would be 64 cubic inches. Number 20. And if you've ever driven upstate, you would have seen these on the side of the road at some points. A silo is a building used to store grain on a farm. A silo is usually formed by taking a cylindrical building and attaching a semicircular dome to the top of it, as shown. Find the volume of the silo to the nearest cubic foot. So the silo is made up of two things. It's made up of a cylinder, which we can easily see, and it's also made up of a hemisphere, or half a sphere. And we know the volume formulas for a cylinder and a sphere. They're both on our formula sheet. So, volume of a cylinder is 1/3 big B times H. Big B, because we have a circular base, is pi r squared. The volume of a sphere is 4/3 pi r cubed. A hemisphere is half of that. So we're going to put a 1/2 in here because we only have half of a sphere. Okay? So here is our formula. Here's what we need to plug into. So now we have, well, we know a few things. The radius of both the cylinder and the sphere is 6. They told us the height was 24 plus a half times 4/3 pi times 6 cubed. And this, since we're rounding to the nearest cubic foot, we can just put this all in the calculator at once and get an answer, as long as we're careful. So, being very careful, here we go. Let me just move this up a little bit. Actually, let me move it down a little bit. We could see it better. Here we go, I think. This will work. All right, it'll work well enough. So, let me just start. Now we can almost see the cubed. Here we go. So clear this out. We have 1/3, I'll put that in parentheses, pi times 6 squared times 24 plus, and you can do this separately if you prefer to, 1/2 times 4/3 times pi times parentheses 6 cubed. Enter. And something went wrong. Okay, something went wrong, and the following went wrong. The volume formula for a cylinder is not 1/3 big B times H. The 1/3 is not there. So I'm sorry if you were confused at the beginning of this. You would be completely right to be confused because I messed up. But now I'm correcting myself. The volume formula of a cylinder does not include 1/3. So please erase that. So anyway, as long as that's erased, everything else is right. So we're going to do pi times 6 squared times 24 plus a half times 4/3 times pi times 6 cubed. And now we get the right answer. So we're rounding this to the nearest cubic foot, which means I don't want a decimal. We get 3,167. This is a volume, so it would be feet cubed. That is correct. So my apologies for the mistake. Number 21. Whoops, actually, we're going to save the... Actually, these we could probably do on this video. So questions 21 through 24. It says, number 21 says, which point is coplanar with C, B, and E? Some of you are having difficulty with this concept. What I said, all right, you have C and B connected by a line. Okay? So here's my line. If I thought about moving this line over to E, Whoopsie, didn't mean to do that either. Edit, undo that. Okay. If I thought about moving this line over to point E, which is the other point I know, what point would it hit? Well, it would hit F. Now let's think about something here for a minute. The plane is the slanty plane that you would put inside the crate. That's the slanty plane and it would also hit point F. Okay? So if you're not seeing that, few ways that you can see it, I just showed you. All right. HG, line HG, is not coplanar with BG. Well, BG together with HG are in the back of the box, which is a plane. So they are on the same plane. DA, let me just retrace. HG is here. DA is here. They're parallel. If I think about a plane, that would be the other slanty plane in the box. No good. That is coplanar with HG. HE, so we have HG and HE. HG and HE intersect. They actually would form the plane that's the side of the box. That's a plane. Now, obviously, we know that the answer is AB, but let's see why. HG is here. AB is here. So we think about this. HG is in the back of the box going up and down. AB is on the other side of the box going sideways. They would never meet with each other. So they would be called skew lines. And skew lines don't form a plane. They're not coplanar. So that would be your answer. 3 pairs of parallel lines. I'll give you a few examples. There are many, many answers to this question, so please don't think these are the only answers. AB, whoops. AB and CD are parallel. Okay? And I really should be putting arrows because they're lines. Some other parallel lines you could have chosen. I'll be a little more exotic here. We could do CB and EF. Okay? I'll be even more exotic. You could even make up lines here. You could be like, well, DH, AG. There are many, many, many answers, too numerous to count for me. All right, skew lines. Skew lines are all over the place as well. So I'm going to pick a line, like I'm going to say AB, okay? Skew. Well, EF would be skew because they're never going to intersect each other because AB is on one side of the crate going back, front to back. EF is on the other side of the crate going up and down. So those would never meet. I'll keep AB around and try to get another skew line. Another skew line could be, say, for example, D to E. D to E is in the front of the box at the top, going side to side, and AB is going front to back. They will never meet. And they're certainly not parallel. Okay? And I'll just keep AB fixed, meaning I'll just leave it alone. And CH would be another line that would be skew to it. Because A to B goes front to back, C to H is on the top going sideways. They will never meet. Whoops. 25 through 32 I'm going to keep for another video. I'm going to try to, like I said earlier on, I'm going to try to tape my hands and some 3D objects. We'll give that a shot. All right, number 33. I should have allowed you more room on the paper for this, so my apologies. If the radius of a cylinder is tripled and the height is divided by 3, it says, what is the effect on the volume of the cylinder? So what I suggest that you do is, at the beginning, you make up a cylinder with numbers. So we have the radius, we have to triple it. So 2 is easily triplable. You can easily triple the number 2. And the height needs to be divided by 3. So I'm going to pick a number. I'm going to pick 6 because 6 is easy to divide by 3. Okay? Old cylinder there. New cylinder. The radius gets tripled. So the radius becomes 6. The height gets divided by 3. So 6 divided by 3 is 2. So this becomes a fat, short cylinder. And now the question is, well, what happens to the volume? Volume formula for a cylinder, let's see if I can get this right this time, is big B times H, where big B is pi r squared because we have a circle base. So we have, for the volume, we have V equals pi times 2 squared times 6. And I'm going to leave this in terms of pi only because it's a little easier to see the numbers. 2 squared is 4 times 6 is 24. So here, my first cylinder, the volume is 24 pi. The next cylinder, same formula, different substitution. Radius is 6 this time, height is 2. So we get 6 squared is 36 times 2, which is 72. So clearly the volume has changed. So the volume does not remain the same. Okay? The volume got bigger, so the volume did not divide by 3 either. So choice D is out. We have to figure out what the volume exactly did. So the volume of the new is 72 pi. If I want to figure out what multiplies here, I can divide by 24 pi, which is the volume of the old. Pi's cancel. 72 divided by 24 happens to be the number 3. So what happened was, if I multiply by 3 from 24 pi, I will get 72 pi. And so therefore, the volume is not doubled, it's tripled. That may seem to be wrong, but let's think about something for a moment. The radius has double the effect if you think about it, because the radius is getting squared. So when we triple the radius, that affects the volume formula not once but twice, because we're doing 6 times 6. So that tripling got affected twice. So even though we divided the height by 3, the tripling of the radius got incorporated 2 times, and that's why overall we triple. All right, number 34. A Ferrero Rocher candy container, pictured below, is in the shape of a square pyramid. Inside the pyramid are delicious chocolate and hazelnut candies in the shape of spheres. The bottom of the pyramid is made up of chocolate candies in a square arrangement of 4 candies by 4 candies. So what that means is the bottom of the pyramid, if you look at the picture real close, okay, you get 4 candies going 4 candies this way. So what happens is, on the bottom row, whoops, let me move that one up. Move that. Okay, not going to work. So what happens on the bottom row is I get 4 times 4 candies, which is 16 candies. All right? In the next row of candies, each candy is placed in the space between the 2 candies below it. So it says how many candies are in the pyramid. Well, the bottom row, we just said, since it's 4 by 4, is 4 times 4, which is 16 candies. Now, what happens in the next row is the following. Whoops. There's all this space. There's space between 2 candies. So what happens is, if you took a look, you get a candy here, and then you get a candy there, and you get a candy there. So what happens is you get 3 candies instead of 4, and then going sideways, you get 3 candies. So the next row, you get 3 times 3 candies, which is 9. Then the row above that, if you follow the pattern, we did 4 times 4, then 3 times 3. So the next row would be 2 times 2, which is 4 candies. And then finally, you get 1 times 1, or just 1 candy at the top. So that would be the top, would be technically 1 times 1 if you wanted to do it, which would be 1, which we see we only have 1 candy at the top. So altogether, 16 plus 9 is 25, plus 4 is 29, plus 1 is 30 candies total. So we get 30 candies in the pyramid. Then it says the diameter of each candy is 3 centimeters. Each edge of the square base of the pyramid is 14 centimeters, and the height of the container is 16 centimeters. To the nearest tenth, how much empty space is in the container? Well, firstly, I want to figure out how much space is in the whole container. The whole container is a pyramid, so I want to get the volume of the pyramid, which is 1/3 big B times H on your formula sheet. Now, each edge of the square base is 14 centimeters. So if I redrew the pyramid for a moment here, each edge would be 14. And big B means the area of the base. So I can do 14 times 14 to get the area of the base. So 14 times 14 to replace big B. Times the height, which they gave us, was 16. And if we type this into our calculator, we will get a number for the volume. So we get 1/3 Let's turn it on. We get 1/3 times 14 times 14. That's the area of the base times 16, which is the height. We get 1045.3 for repeating. So we get the volume of the pyramid is 1045.3 repeating. Okay? Now, each candy is a sphere. Okay? The little round candies, they're spherical. So what we can do is get the volume of one of the candy by using the volume of the sphere formula, which is 4/3 pi r cubed. They told us the diameter of each candy was 3 centimeters, which means that the radius is half that, or 1.5. So we're going to type this into our calculator for the volume of the candy. Volume of the candy is 4/3 pi times 1.5 cubed. And we get this. We get 14.137166694. That's one candy. I forgot the number. 14.137166694. But we don't have one candy. We have 30. So what we're going to do now is we're going to take that number to account for all the candies and all the volumes. We're going to multiply that by 30, and we're going to get 424.1150082. 1150082. So we multiply this by 30. This is the volume of the 30 candies. So they only take up 424 cubic inches of space. The pyramid has all this space in it, so there's actually quite a bit of space that's actually left empty in this pyramid. That could be one reason why they try to sell it to you this way, because it looks like it's so much more than it is. So empty space would be 1045.3 repeating minus 424.1150082. So I want to type this in. If you want to type in 1045.3 repeating, just type in as many threes that will fill up the line, okay? Minus 424.1150082. And we get 621.218 blah, blah, blah. And they're asking us to round to the nearest tenth. Nearest tenth, they're asking us to round to. So we're going to take that number and round it correctly to the nearest tenth, which is going to be 621.2 cubic inches of empty space. And that's it. All right, my apologies. We were not done there. I had neglected to put the last two problems in. Sorry, and here they are now. Find the volume of a cone whose lateral area is 320 pi feet squared and whose diameter is 32 feet. So again, we're being asked to find the volume of a cone. That's a formula off your formula sheet, which is 1/3 big B times h, which is 1/3 pi r squared times h. We know the lateral area of the cone. So we're going to write the lateral area of a cone formula as well. The other thing we always do when we have a cone is we draw it. So here's my picture of the cone. We always put the triangle in it. All right, so now we have the lateral area being 320 pi. So we're going to fill that in our formula. Equals pi times, the diameter is 32, which is helpful because that gives us the radius of 16. Times this equation now has all numbers except L, which is the slant height. So now we can actually use this blue equation to solve for the slant height. So we're going to put the 16 in front, and we're going to divide both sides by 16 pi. The pi's will divide out, and 320 divided by 16 is 20. Script L stands for the slant height. So we have to put the 20 on the slanty part of the triangle. Now, let's bounce back over to the volume formula because we want to find the volume of the cone. So volume is 1/3 pi times the radius, which is 16, times the height. Well, height refers to the regular height, like if you were going to the doctor's office. You stand straight up. He tells you to stand nice and straight and tall. So we need to figure that out. We're going to use the right triangle inside the cone, and we're going to use the Pythagorean theorem. So Pythagorean theorem, a squared plus b squared equals c squared. I'll leave that as a. 16 is the radius, 20 is the slant height, which in this case is the hypotenuse, or in every case, in terms of the cone. We have a squared plus 16 squared is 256 equals 400 minus 256 from both sides. So we get a squared is 144. Taking the square root, the altitude or the height is 12. So that number is going to go right there. That's the real height of the cone. So now we're going to multiply everything because we want to leave our answer in terms of pi. Actually, it doesn't say that, but if it doesn't, we can leave our answer in terms of pi. So we're going to multiply everything but pi. We're going to have 1/3 in parentheses, skipping pi, 16 squared times 12. And so we get 1024 pi. Feet cubed, since it's volume. Since it did not specify, you could also give me the decimal. So I can multiply this by pi, and you could also write down that decimal. I won't. It's just easier to leave the answer in terms of pi. So if they don't tell you what to do, you can leave it in terms of pi or write the full decimal. To avoid points off, I would just leave the answer in terms of pi. All right, number 36. It says, let me just lock this first so it doesn't move around on us. A compound solid is shown below. The height of the entire solid is 20 inches. So if I measured from the bottom here to the top here, that would be 20 inches. So I'm going to put that out here, actually. That would be 20 inches. The diameter of the solid is 10. So the diameter of solid is 10. The radius is 5. So radius here, radius there of 5. If the slant height of the cone is 13, that's this part here, they want us to find the volume of the solid in terms of pi. Well, what is the solid made up of? Well, on the bottom you have a cylinder, and on the top you have a cone. And basically we need to find the volume of the cylinder, find the volume of the cone, and add them up. So the volume formula for a cylinder, whoopsie, said off the page, strange. Volume of the cylinder is big B times H, where big B is pi r squared since we have a circular base. Volume of a cone is 1/3 big B times H, or 1/3 pi r squared H. So now we have to put in the information that we know. So I'm going to start with the cylinder. The volume is pi times the radius we know, times the height. The height of the cylinder goes from here to here. We don't know that. So I want to leave that blank for now and hop over to the cone. Volume is 1/3 pi times 5 for the radius times the height of the cone. Don't know that either. We don't know how high the cone is. But we do have the slant height and we do have the radius. So if you notice, that missing height can easily be found using the Pythagorean theorem. So that's our first step, is actually we need to find the height of the cone first. Height of the cone, I'll call that A for now. We have a squared plus b squared equals c squared. So a squared plus 5 squared is 13 squared. A squared plus 25 equals 169. Subtracting 25, we get a squared is 144. Let me just move this down a touch. And so taking the square root on both sides, we get a is 12. So now we have that this a is 12. So now we have the height of the cone. Fantastic. We can now get the volume of the cone, which I'm going to leave in terms of pi. That's what the problem asks us to do. So now we can get the volume of the cone, no problem. We have all the information we need. So I'm going to put in 1/3. Skip pi, as we're keeping pi in the answer. 5 squared times 12 equals 100. So now the volume of the cone is 100 pi. All right. Well, still left is the volume of the cylinder. And we said we were leaving a space there to fill in the height. Well, what's the height going to be? Well, we know from the blue, okay, all the blue stuff is 20. The red part is 12. So to figure out this green part, we can do 20 minus 12, which will give us 8. That 8, guess what? That's the height of the cylinder. So now we can put that in for the height of the cylinder. I'm going to leave the answer in terms of pi. So 5 squared times 8, if you do that on the calculator, you get 200 pi. So the volume of the cylinder was 200 pi. The volume of the cone was 100 pi. And we want to find the volume of the whole thing. So we can take 200 pi plus 100 pi. Now, if you think about how to add these up, instead of having pi, think about this for a moment. 200x plus 100x. Well, instead of the pi, I'm putting an x in. Well, we know that's 300x. Okay? So instead of having an x, we have a pi. It's like adding like terms. So 200 pi plus 100 pi is 300 pi. And units is still volume. So our volume, since our problem was given in inches, volume units would be inches cubed. So final answer, 300 pi inches